Okay, so this set of videos and this topic is going to be about pulleys and how we deal with pulleys. And what I need to say up front is two things: that we're going to be idealizing these pulleys, all right? Which is to say that the pulley itself doesn't interfere with what's happening. Okay, and that's an okay assumption in statics. Now, when we get to dynamics, that's not a great assumption, but it's still at least a starting point. And so in our idealized world, when you have a pulley, what happens with the rope, so here's our pulley, what happens with the rope on either side of the pulley is you're going to have the same tension on the left as you do on the right. Okay. And so the pulley doesn't interfere with it at all. Okay. All the pulley does for us, as far as we are concerned, is it redirects a force. It can be used to change the direction of a force. Okay. And in that, only a tension. Okay. So let's check out what we've got here. And so the load is down there at the bottom, the 600, and it's being held up by this contraption here of 3 pulleys working together. And the rope is actually goes up, across, and down, and then ties on right here. Okay, it ties on right there. And what we want to do when we've got a situation with pulleys is we got to kind of figure out each pulley all by itself, what's happening. Okay, what's happening with that particular pulley when it comes to the forces. Okay, so let me get that off of there. And what we're going to do is we're going to go one piece at a time. So if I look at this piece right here, okay, then you can see here's my bits of rope providing tension on either side, here and here. Okay, and then I've got these other forces going on where I'm tied on here, and that's going up. And so that's the thing that's actually holding up everything. All right. But then that particular pulley is also holding up the one below it. Okay. And then we're going to see that that's actually pulling up here too. But that's getting ahead just a little bit. Okay. But we put that over here. So for my pulley right there, and you know what? Let's give these things some labels. Otherwise, it's going to get out of hand. So I tell you what, let's call this guy pulley. Oh, they've got labels. Cool. I don't have to do it. Okay, so that's pulley C. There's A, B, and C right there. That's nice. That's nice. Okay. So pulley C is in equilibrium from every standpoint we could think about: the vertical aspect of forces, the horizontal aspect of forces, and all the moments. Okay. So we could write equations if we needed to. Whoops. Let me kind of move this over here. We could say that we've got R up minus P down minus T down minus P down. All that has to be equal to 0. Okay. And so R is going to have to do, it's going to have to carry a lot. Okay. Now let's go to B. Okay. So we got pulley B, which is right here. And here's that upward force we were talking about earlier. And here are the tensions coming down off of due to our rope right there. And we could write an equation of equilibrium for that one. We would say T up minus P is equal to 0. Okay, so really that'd be T minus 2P. And we could see from that relationship there, if we needed to know T, we could see that T is equal to 2P. So we've got a relationship there. So T is actually doing double duty, literally double duty compared to whatever the tension is. Okay. Then let's get to our last pulley, pulley A here. And it's this guy. And here is the external load. So that's our 600 right there. And then I've got 1, 2, 3 pulleys coming up. So I would write down over here on this other side, I'd have 3P minus the 600. Okay, so 3P is 600, which tells us that P is 200. Okay, just like that. So P is 200. And great, so there we go. Okay. So if P is 200, then that means the T is going to be 400. And it means that R here is actually T plus 2P, which is going to be 800, right? Nope. Oh, I was trying to undo and I did the wrong thing. Okay, so 2P is 400, T is 400, so it's 800. There we go. Okay. Okay, so in terms of R, if we had to know what's happening with R, we wouldn't actually have to go through all of that if we'd known P already. Okay, so let's assume we know P. We could have said, well, let's look at this thing as one object here, and as an object here, I've got an external force P, I've got R, and I've got my 600. And so you can see right away, the thing that's pulling up, R, it's got to be the 600 in addition to whatever P is. Okay, so it's doing extra. Okay, so if I'm lifting up something that's got a weight of 600 newtons, and I'm pulling like this, I need to make sure that where I'm connected up here at the top, it can handle more than 600. If 600 is its limit, I hook this thing up, it can hold 600, okay, until I start pulling on it, and then the whole thing comes crashing down on top of my head, and then lawyers get involved, and there's ambulances and stuff. It's just a mess, okay. Okay, okay, one other thing now, you can see in this particular case, really everything came down to what was happening over here. Okay, oops, I lost my yellows. Okay, sometimes with pulley situations, you can spot that right away. Okay, sometimes you can spot that right away. And this pulley situation is one of those where it's so simple. We could have just said, oh, hey, you know what? Let's borrow from the method of sections. Let's just cut this thing right there. And I can see I've got 3 tensions up and a 600 down. Boom, I know what I'm dealing with. Okay. They're not usually going to be that straightforward, but they can be. Okay. And so when that happens, just give a little fist pump and be happy about that. All right. So let's look at another pulley situation here. Okay. So here we've got an elevator and a shaft. And I do need to tell you about a little code word here. And we don't usually deal with this code word until dynamics, but see where it says it's at a constant speed right there. That's important. That means the system is not accelerating. If the system is accelerating, that changes how we have to think about some things. So the fact that it's a constant speed, that works to our advantage. Okay, we can be like, all right, that's great. Okay, so now let's actually look at our pulley system. Let me make it just a little bit bigger here. And And so what I'm going to do, I'm going to trace. Let's start at A. We've got a rope that comes down. And that's a little too fat. It's too fat of a line for my liking. Maybe I can make a thinner one here. I'm going to come down. Okay, I feel a little better about that. Here. Loops around there. Loops around here. And it ties off right there. So that's one cable. Okay, so everything we know there about the tension is going to be uniform throughout that cable. Okay, now again, that's an idealization. In reality, a cable can be thick and it could be heavy, and the weight of the cable is not something we're taking into account right here. All right, that would definitely alter our analysis. So again, we're sort of operating on a KISS principle. Keep it simple, silly. Now let's look at another cable. Let's go ahead and start over at F just to see what we've got. This guy comes down, up, around, and that attaches to C. Okay. And this is clearly not a practical mechanism. This has just been put together, excuse me, has been put together as an exercise, okay, for us to think about. Okay, so let's think about the car itself. What's happening with the car? So what we know down there with the little elevator car is we're going to have tension up there, here, and here. Okay, now technically I've got a connector down here like this, but we're not going to worry about that. Okay, that's an unnecessary detail. It doesn't alter anything about it. So that one cable has a certain tension, and that tension contributes 3 times to supporting the weight of the elevator car. Okay, let's look at what's going on with the blue cable. So again, we're going to have something up here and something up there. And then, of course, there's the weight of the elevator car there. Okay. Now, I've ignored the normal forces that are at work because they're not going to have any impact on the pulleys. But your text went ahead and did that. And so you can see their analysis. And so if I sort of translate the colors over here, so here's green, 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 blue, and blue. Okay. And what you see, if I want to make an equation, is that I'm going to have the weight down. So let me put that in here. And then we're going to add 2 T2s and 3 T1s are equal to 0. Okay. Just like that. Okay. So by thinking about what's happening with the car, then I get that relationship. Okay. Now, if I want the tension T1 and T2, if I want those values, I'm going to need more information because I've got one equation and 2 unknowns, and that's untenable. That isn't going to work. Okay. But I can come up and I can think about this pulley right here. Okay. Which your book has drawn here. Okay, and now let me put our colors on there so we can keep things straight. T1 is the green, and T2 is the blue, just like that. Okay, so now I get another equation, which is going to be that this is T2 up minus 2T1 down is equal to 0. Okay. And at this point, then the analysis part is done, the engineering's done, the physics is done. It's just an algebra problem with 2 equations and 2 unknowns. We just solve that. Okay. Piece of cake. Okay. So what you want to do, is when you're looking at these things is trace the cables, make sure you understand where that cable's going, where it's been, all that, and then start to pick apart each piece and see how those cables and the other forces are operating on the object. Okay, now this one is a little more complicated situation, and so we've got a guy, and he is standing on this platform, okay, and what we want to try to do is figure out what's the tension at B and the normal reaction of the man on the beam. Okay, and so first let's go ahead and trace the cable. Make sure we know where the cable's going and what it's doing. All right, so there's our cable there. And if we go ahead and put some forces, we got this, okay, on the guy here and here. Okay, of course the guy's got some weight, and then there's a normal force acting up here. Okay, just like that. And so if we just think about the guy, all right, then we've got this relationship here. Okay, here's our situation. All right, and so 2 T1s are holding him up, in addition to the normal force. So this one I put in as red right there, and then here's our 2 forces from the tension there. Okay, and so one relationship that we're going to have just by looking at the guy is we're going to see that the weight is down. We're going to have 2 T1s, that's the green, plus the normal force, and your book is calling it from the man, like that. So there's one algebraic relationship among our forces right there. Okay, the other thing to do is to look at the beam. Okay, and so the beam, from the beam's perspective, we still have the tension at B, but from the beam's perspective, there's a normal force down from the guy right there. Okay, so we don't want to put the weight of the man. We can't put the weight of the man because the beam doesn't feel the whole weight of the man, because the man's holding on to that thing. Okay, so the beam might only feel maybe half of the weight, or a third of the weight, or maybe 3/4 of the weight. We don't know how much of the weight the beam actually is going to feel. It's going to feel something. We just don't know what it is yet. And then we're going to have, I'll do this guy in blue, I guess. Reaction force from our support at A. Okay. So, whoa, that was crazy. Okay, so if we think about the beam then, all right, so here's that tension we talked about. Here's the force from the man. And here's the reaction force from the pulley right here. And then I guess I didn't read it closely enough. We're going to have to deal with the weight of the beam. So let me put that in there. There we go. Sometimes the weight matters, sometimes it doesn't. Just read the question carefully, and clearly I didn't. Okay. There we go. Okay. And so if I just use that part right there and try to write down an equation, Okay, I'm going to have AY up, G down, the weight for the beam, and I'm going to put a little B on there. And the normal force down from the man. So that's what the beam feels from the man. And then the tension is up like that. Okay. And so we can see that the reaction force and the tension, that's T1, together have to support the weight of the beam plus what the beam feels from the man. Okay, just like that. Okay, so let's zoom out just a little bit. Let's think about our unknowns. Okay, so I'm going to identify those. We don't know T1. We don't know NM. NM and T1 both appear down there. So I've got two unknowns. I've got two equations. Except actually I don't know AY either, which means I've got three unknowns and only two equations. So what that's going to mean is I'm going to have to look at my moments and try to figure out what's going on with those. Okay. So the way I would proceed with this is I would put my pivot. Where would I put my pivot? Yeah. I think I would put the pivot, I would try it here first at A. Okay. That's going to give me a third equation, and I can use that equation probably with this one up here to solve for T1 and NM. That's going to work out for me just fine. Okay. This picture over here, I think they're just showing us all of these things together. Okay. I don't really care about that, but I do want to show you, if we look at the moments acting, let me go ahead and write that equation for you. Okay, so if I look at, if I look at my moments around A, then we're going to have minus 0.8 in M, okay, minus 1.5 G for the beam, plus 3 T1 is equal to 0. Okay, so then there's my two unknowns, and I can use this equation and this equation together and crack that nut. Okay, just like that. Okay, let me see. There's one more I want to take a look at here. So this is a super simple one. Let's end this video with this one. So we're told that we've got a weight here of 60 pounds, and we want to try and find out what P is. So we want to trace our cable. It's coming around like this. Okay. And so we're going to have up, up, up. And so this is one where we can basically look right at this thing. You borrow from our method of sections, cut this thing right here, and see that what we're going to have is 3P has to be equal to 60. Okay. And we're done. P is 20. Okay. Again, that's not going to happen very often, but when it happens, great. Let's take it with gusto. Okay. So I've got a couple more examples that I'm going to do for you that are fundamental problems. So this is a fundamental problem. So I'm going to do two more fundamental problems for you. In chapter 6, there's a ton of examples that are worked out very nicely. You need to read through and study those examples carefully. Now, those examples are going to have pulleys in them. For now, just study the pulley examples. We're going to get to all the other examples later, okay? But here's one of these cases, guys, where you have to develop proficiency. It's not good enough to be able to go, oh yeah, I can work through this. No, you've got to be solid. You've got to be competent. You've got to be confident when you do these things, okay? So let's talk about proficiency real quick, okay? So usually when people talk about proficiency, they talk about 4 different things, okay? So step 1, when it comes to being proficient at any skill, step 1 is what's called unconscious incompetence. Okay. And basically that means you're so bad at the thing, you really have no idea how bad at the thing you are. Okay. You really have no idea how bad that you are. Okay. Now, closely related to that is something some of you guys may have heard of called the Dunning-Kruger effect. And the Dunning-Kruger effect is when you have people that are unconsciously incompetent. They have, in other words, they're so clueless, they don't know how clueless they are. But they're ignorant of that, and they think that they're competent anyway. Okay. So this kind of thing happens all the time if you get into conversations with people on Facebook or social media or something like that. Just, okay, these guys, they have no idea what they're talking about, but that doesn't stop them from thinking that they're an expert. What they really are is they are unconscious and unconsciously incompetent. They don't know how much they don't know. Okay, now, the second level, okay, is what's called conscious incompetence. Okay? So here's where, all right, you enter in a situation, you think you're the bomb, you're at step 1, and you get your ass handed to you. Okay. And then you're like, oh, okay. Now you know how much you don't know. All right. You know how much you are aware that you are incompetent. Okay. Which gets us to step 3. Okay. Which is what's called conscious competence. Okay. Now that means you are aware of how to do it and you are able to do it. Whatever it is, whatever the skill is, whatever the knowledge is, you're aware of it and you're able to do it. So you've moved from not having any idea and completely bungling it like a clown to knowing you've bungled it like a clown to now you know it, but you're not going to bungle it. Okay. And so that's good. That's good. That's a good progression. Okay. That's not good enough. That's not good enough. You have to proceed to step 4. Step 4 is unconscious competence. Okay. Unconscious competence. So this is like, you don't have to think about it. Okay. You don't have to think about it. So, you're good at it, but it comes effortlessly to you. Okay. You used to not know there was such a thing as addition. So you didn't even know you were bad at it. Okay. And then you figured out, oh, hey, there is such a thing as addition and I'm bad at it. And then you got to where you had some competence. Okay. And so you were like, okay, I've got 2 and I've got 3. Okay. And so you were like 1, 2, 3, 4, 5. Aha. Okay. Great. Right. But you don't want to be there 1, 2, 3, 4, 5 for your whole life. Okay. You need to get to where you can go, oh, 2 and 3 is 5. I'm done. I got this. Okay. Anyway, when I talk about getting really good at something, That's what I'm talking about. Okay. When we talk about being proficient at something, that's what we're talking about there. Okay. So that was a bit of a tangent. Okay. Normally I charge a lot of money for that kind of information, but you get it for free. It's included with your tuition. So you need to go through all of those examples. Okay. And it's not good enough to go, oh, I understand this part. I understand this part. I know this part. You need to be able to duplicate it quickly and easily. Okay. That's when you know you've reached step 4. And that's going to help you when you get ready to do your problems. Okay. Spend the time thinking through the examples. That's going to make your homework go faster. You're investing in yourself and your skills. Okay. Anyway, enough of tangents. Let's get off of here, and I'll get to the next videos.